discriminating dye, binds free amine groups, and so the dead cells are the ones that the dye gets into and binds everything. So they're right, I want to exclude those. Maybe I'll take my polygon tool here and do a nice, if I hold down shift, it gives me 45-degree angles, and when I click, it creates a point. So I can click, 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 and close, and call this live. Call that live through, and now I'm going to double click on that one and go down to my live cells, and we can start looking at the markers. In this case, I'll start with CD3 on the X, and maybe we'll look at class 2 HLA-DR on the Y, because that'll show me my 3 distinct subpopulations here in the PBMC. These are my CD3 positive T cells. Up here, I'm going to have my HLA-DR class 2 positive monocytes, dendritic cells, and B cells, and then down here is going to be mostly NK cells. Now, I don't really like that my data is squished on the axis here, and so I'm going to move that off the axis by going to my Transform Data Display button. It's located next to the drop-down menus for the axis labels, and I have the option to go linear, log, or customize the axis. And I will recommend with fluorescent data to really go to customize axis and use this bi-exponential transformation method, which really allows you to bin data around 0 in a linear scale, and then as you go further away, it'll turn into a log scale. So you can see the changes in fluorescence in the log scale, but you can actually have negative events and have things be around 0, more visually appealing. There's 2 things you can do with this. Either there's a slide bar here. You can add additional decades on the back end below 0 to spread out your data, and that's essentially what I need to do here is move my data off the axis. I can also move the width basis. This changes how many bins of data are in a linear scale around 0. And so I can squish the data around 0 by increasing the width basis, or I can make it wider around 0 by decreasing. There's no right or wrong way, but I do find that widening your population around 0 gives you more space in that transition zone to correctly apply your gate and discriminate positive from negative. But in this case, I'm just going to add some additional negative, and I can either do that just for, I'll add 1 additional negative decade just to the Alexa 700 CD3 parameter. If I hit apply, notice how it moves over, but this HLA-DR parameter stayed the same. And I want to go ahead and change both of these, and so I can do them one at a time by going, or I can hold down Command and select any number of parameters that I would like and change them all uniformly. And so I might start with this analysis, taking all of my compensated fluorescent parameters, adding some extra space, and keeping the width basis at 10, and hit apply. And now it gives me my data in the middle, and I can actually be sure that I'm not cutting off events when I draw my data. Transformation only changes the display of the data, not the actual underlying numbers. And so it doesn't matter if you squish your data on the X and Y, or if you make it all wide or make it short. It does not matter. The numbers of the MFIs are still going to be the same. The frequencies of positivity of your gates are still going to be the same. The gate scales with the transformation. It only is for visual appealing. But you can make very pretty data using this transform button, and that's what you want to show in lab, right? So I'm going to go ahead and start gating my actual markers. In this case, I'm going to use my polygon tool, and I'm going to make a gate here to incorporate my CD3 positive T cells. The CD3 positive. All right, this is an example I like to give of why 1D histograms are not the best tool for gating on 2-dimensional or multi-dimensional data, because if I change this into a histogram and I use my bifurcation tool, and I just pick this down here where it seems appropriate, and then I look at that gate and then change it back to my HLA-DR marker, you can see I'm clipping this cloud of some other cell type, and I don't want those. This is my only T cell marker, definitively here. I could have some monocytes and B cells. I don't want those. And so I find that for gating purposes, it's almost better to gate on 2 dimensions rather than 1. I can close all the windows with a hotkey. I'm going to delete those 2 gates that I just made the ranges, and I'm going to pick back up on the CD3 positive population, and then I'm going to start looking at my T cell markers. So I'm going to look at CD4 versus CD8, And now I almost have too much space here, so I wanna make better use of my screen real estate. So I'll go to Customize Axis, and I'll just highlight the CD4 and CD8, and I'll bring those down. Maybe just leave a little extra space. And now I have more space there, right? This is a great tool, distribution for using quadrant tools. In version 10, there are 3 different quadrant tools. One is the classic straight quads, right? Which you have also on the Mac. But I also have what's called a curly quad, which actually takes the spreading and compensation spillover into account mathematically. So I like those these days. Fun to play with. And then I have spider quads, where you set the center vertex and then you can change the way they meet the x and y axes. Those are really helpful if you have distributions that aren't very well separated, and you're going to have mouse sleeves or something. You need to make angles that separate the markers appropriately. But for me, it doesn't really matter. I'll just leave this tool in here. Actually, I'm really fond of these curly quads this past week or so. So I'm going to do my curly quad gate. And then I'm going to double click just on the top left CD8 positive single cells and take a look at my readouts. I'll point out here at this level that you can actually keep this same plot open and now move up the gating tree and see how your gating actually subset down to the population of interest. So if I go up to live cells, to lymphocytes, to single cells, to time, and to all state, you can see how my gates are subsequently reducing the number of events